Okay, so let's take a look at number 3 from today's challenge worksheet. So we know that h of g of x is equal to f of x. That's given. Maybe we can rewrite this as h of g of x equals f of x. And then we know what g of x is, so we can replace it with what it equals. So we have h of x to the 12th minus 1 equals f of x. That's what we have so far. Now let's focus on f of x. They tell us that f of x is a parabola, and they tell us where the vertex is, right? So maybe we can focus on vertex form of the parabola. They say that the vertex is at the origin, so we know the vertex is at 0, comma 0. That goes in for h and k. Now we have to find a. So for now, we know that h and k are 0. So we have y equals a, x minus 0 squared plus 0. And then they tell us a point. They say that square root pi, comma pi is a point on this parabola. So we can plug in those numbers in for x and y, respectively, to discover the value of a. So that would look like this. Pi equals a, square root pi squared. The zeros can just disappear into thin air. So this is pi equals, the square root and the square knockout is just pi. So this is a times pi. So a times pi is pi. So a has to be 1. So we know a is 1. We know h and k are 0, 0. So our parabola is just 1x squared, or just y equals x squared, right? The parent parabola. But instead of y, I think it was called f of x. So going back to the equation we had earlier, we have just seen that this is what we have so far. This is what we have right here in purple. Leave the purple there. Let's just do some learning here in green, let's say. So forget about all that for now. Just leave it boxed in for now. Quick demonstration. Let's say that you have some random equation that says something like this here. Watch. Let's say you have something like that. Okay, f of x plus 3 equals x minus 1. We're so accustomed to just seeing like f of x, right? Not f of x plus 3. So what can I do to this to make it to look just like f of x? In other words, how can I get rid of this 3? Some people would say, well, just go minus 3 to both sides. Well, you can go minus 3 both sides, but these do not cancel. Now, that doesn't happen because the 3's in the parentheses, it's protected. So instead, for a situation like this, you want to plug in a certain number that would knock out the 3. Someone would say, oh, plug in negative 3. Not quite, because if I plug in negative 3, it would become f of 0 equals negative 3 minus 1. Right? Because if you plug in negative 3, they cancel. And it's f of 0. But I want f of x, right? I want x to be preserved. I want x to be preserved, and I want the 3 to also go away. So what you should plug in this situation is x minus 3. If you plug in x minus 3 in there and in there, you can see that these 3's would knock out and the x would be preserved. So watch, just to finish my own example, if I plug in x minus 3, it would be f of x minus 3 plus 3 equals x minus 3 minus 1. And these 3's would knock out. It would just be f of x equals x minus 4. Okay? Now, let's stay here in green. Let me just change this up a little bit. What if you have some random equation in a book that says something like this here? In this situation, how would you get rid of the power 2? Let's say you just wanted to say f of x. I don't want this power of 2. I want it gone. So in this situation here, the thing that we should plug into both of these x's would be the square root of x, because the square root would knock out the square. You see that? And in general, what if you had, let's say, x to the power of like 7 equals x plus 5 or something? In this case, what would you plug in for the x to get rid of the 7? You would plug in the 7th root of x, and so on and so forth. So now let's go back to our problem. Let's go back to our problem here. This is what we have, right? This is what we have. So now let's say we want just h of x, right? We want just basic h of x. I don't want this 12 and I don't want the 1. I want them gone and I want them gone now. How about we focus on the 12? Let's make the 12 go away first. We can take baby steps. Let's make the 12 go bye-bye. So what you can plug in here, and of course there, would be the 12th root of x, the 12th root. Let's plug in the 12th root of x in for both of those x's, right? So in there and in there, we're going to plug in the 12th root of x. And it would say this, h of the 12th root of x to the 12th minus 1 equals the 12th root of x to the power of 2. That's what it would say, right? And this works out nicely because here in red, let me switch colors. Here in red, these knock out. So we're left with, on the left, we're left with h of x minus 1 equals the 12th root of x, all of that squared. Now let's focus on the 1 and let's get rid of the 1. So here now, going in for both of the x's, we could plug in the quantity x plus 1 because that will preserve the x and the 1's would knock out. See that? So that this would give us up here in the top right, we would be left with h of x equals, we're left with the 12th root of x plus 1, the 12th root of x plus 1, all of that protected to the power of 2. And I think now we can proceed to the goal. Let me make that clear. Let me just extend it above the 1. I think now we can proceed on to the goal because the goal was to find h inverse of 2, right? That's the goal, h inverse of 2. So now let's focus on the goal, h inverse of 2. So up to this point, we have discovered that h of x equals the 12th root of x plus 1 to the power of 2. And the goal is to find h inverse of 2. And we know that this 2 can be sent to one of two locations. You could send the 2 as the input into h inverse, or you could take the 2 and you can send it as the output into h, right? Two options. Plug it in as the x for h inverse, or plug it in as the y in h. And that's what I want to do. I want to take the second path. I want to take the 2 and plug it in as the output in the original h. And that should give us the final answer. So we should have 2 equals the 12th root of x plus 1 to the power of 2. Solve for x. How about we solve for x by getting rid of the 2, then the 12, and then the 1 in that order. So to get rid of this 2, here in red, we can square root both sides. We can square root both sides. So we'd have square root 2 equals the 12th root of x plus 1. And now here in red, we can raise both sides to the power of 12 because the 12's knocked out. And on a calculator here, that would say 64. On a calculator, that would say 64. And then bump the 1 across this side. So 63 equals x, and that represents our final answer. So now that you've seen how a problem like this can be done, be ready to have some fun tomorrow on your team test.